Hey guys, you should have just finished your 20 questions on the form and now watching this video. If you've done your questions, I'm going to go over the questions and give you the correct answers so that if you do it properly, you should make 100 on this form. So here we go. Unit 4 test review. Your test is tomorrow. Right, question 1 is mean absolute deviation. Remember, these tables are available in your team under files, under class materials in Unit 4. It's Mad Organizer. Okay, so either print this off or at least make you several on paper before you start. Especially tomorrow on your test, make these up because, guys, it's going to be very hard to keep it straight if you don't make a table. So get your table made and let's go. So mean absolute deviation. Okay, remember, mean, we got to find the mean. So we're going to take all these numbers, we're going to add them together, and we're going to divide it by 1, 2, 3, 4, 5, 6, 7, 8, and that gives us 87.25. Okay, so my mean is 87.25, so I'm going to come here, right, 87.25, 87.25, 87.25, 87.25, 87.2, right all the way down this column to get to your bottom of your numbers. 0.25, 87.25. Okay, then you're going to go and you're going to subtract 79 minus 85 minus 92 minus 90, 88, 87. Subtract all those. Remember, the distance is always a positive number. If I go from here to Greenville, it's 30 miles. Driving back home from Greenville, it's not negative 30, is it? It's still 30 miles. The distance is always positive. We're not going to have any negatives in mean absolute deviation. Absolute value is always positive number, since the distance from 0. So when we subtract these, this is going to be 8.25, 2.25, 4.75, 2.75, 0.75, 0.25, 3.25, and 5.75. You should have all this done on your paper. And then we're going to add all these numbers together. Add 8.25, 2.25, 4. All those together. And divide by 8. And we get 3.53, which is about 3.5. So on number 1, you should have gotten B for your answer. Okay, that's the only one I'm going to actually work out. I'm going to just go through the rest of them real quickly on mean absolute deviation because I'm not going to work all those out. That would take forever. Okay, so add them up, divide them to find the mean, subtract, take all those subtracted answers, add them up, divide them to find the mean absolute deviation. Okay, it's the average of the distance. Okay, so number 1 is B, 3.5. Number 2 is mean absolute deviation again, and that one is going to be C, 4.3. So number 2 is C. 3. Okay, 3 is a trend line. It's a scatter plot with a line on it. Your test won't have lines, but this is how you're going to do the test questions. You're going to draw a line through them. Okay, so we have the relationship between outside temperature and the number of beachgoers at a small beach in South Texas. Okay, so what we need to pay attention to here is our axis. The y-axis is the number of beachgoers. The x-axis is the temperature. So based on the data, what is the best prediction for the number of beachgoers if the outside temperature is 90? So temperature is 90. So here's what we're looking at right here. And we're going to follow this line up till we get to the line or our set of our data. And so here's our line. And if we say 650, which is up here, 550 is here, 400 is here. Or sorry, 550. Sorry. 550 is about here. See that? 550, 650 would be here. So that line doesn't matter. And 400 is about here, and 150 is way down here. So the one that fits in our data is this 550 mark. Okay, so that one's 550. I'll do better on the next one. Okay, so here's another one. And here we're based on the data, which is the best prediction for the total number of concession sales with 200 attendees. So attendees is down here, sales is here. So 200 attendees. So we're looking at this line here. And we have 200, 600, 900, or 1200. And obviously on this one, the one that falls on our line is the 900. Okay, so when there's a line, you're just looking for the one that falls on the line. When there's not a line, we'll get to those in a second. You're kind of make your own line. Okay, question 5 is mean absolute deviation again. This one is B. Okay. Number 6 is another trend line. Now this one says, based on the data presented, most reasonable prediction for the number of candles that must be sold to earn $600. So here we're looking at $600. Well, this is candles, this is money, so 600 is over here this time. So we're following this line over till we get to here. And if we're doing that, then we have 200 is here, 250 is here, 300, or 400. The one that's on our line is the 300. That's how you're going to do your scatter plots, guys. Oh, oops. Now I'll go down one more. Okay, question 7. So the scatter plot shows the relationship between teacher salaries and teachers' years of experience. Each scatter plot suggests a linear relationship between two sets of data except for. So here we're looking for the one that is not linear and the one that doesn't make a line. So this makes a line going up, makes a line going down, makes a line going up, and these points are scattered everywhere. There's no line here at all. So this one is District 11. So that one's that one. Okay. Number 8. Oh, sorry. Okay, number 8 is direct variation. Remember, direct variation is proportional. Okay, so there's several ways you can do it, but the easy way to do this is to take y over x, so 30 over 12 gives us 2.5. Yeah, 2.5. So you can look here and say 0.8 divided by 2, 3.2 divided by 8, that gives us 0.4, not 2.5. 5 divided by 2 is 2.5. 10 divided by 4 is 2.5. 15 divided by 6 is 2.5. And 20 divided by 8 is 2.5. The 2 divided by 2 is 1. And this 2.5 divided by 2 is 1.25. So the one that equals this is going to be G. Okay, so find the one that matches. All right. Number 9. This is a scatter plot that does not have the line in there that you're trying to make your own line up. So what we're going to do is we're going to plot these points on our line and see which one matches. Okay, so if Kim Dog has a shoulder height of 20 inches, so height is here, 20 inches. So this is our line we're looking at. Okay, so we're looking at 34 pounds, 12 pounds, 20 pounds, or 48 pounds. So we're looking at this data here, and the line that runs, or the dot that goes through our data, is this one right here at 34 pounds. So that's our answer A, 34 pounds. Okay, that's how you're going to do those. Number 10. Jeremy collected data about student heights and their scores. After making a scatter plot to show the relationship between the two sets of data, he concluded there was no correlation. Which scatter plot supports Jeremy's conclusion? So no correlation means the one that's scattered all about. Okay, A is a line, C is a line, and D is not a line, but it is a pattern. There is maybe a curved line. It's not a straight line, so it's not linear, but it does have a pattern to it. So B is the one that are all scattered around. So B is the one that has no correlation. Okay. Number 11, Snow Cone Company. Just kept track of sales over the last 7 years. We want sales in 2008. So sales in 2008. So here's our line here. This one on the review, I gave you choices. I want to say I did, I think they were 150, 2, 250, and 3 maybe, I think. You can see this one is the 200. Okay, so this answer is 200. It's multiple choice on the review, so that was 200. I don't remember what letter that was, but there you go. All right, number 12. Mark was studying salaries at his company. He graphed out 12 different employees. He is hiring a new employee with 10 years experience. So 10 years experience is here. So this is our line here. How much money should he offer the new employee? So 75, 60, 70, 80. So here is 75 on the 10. 125, so here's 125 right here. 100,000 and 50,000. 40, there's 50 right there. Which one is within our line of data? We continue this line on up. See, that's why I hate these problems. 125 will be over here. Oh goodness. This is our line of data here. Oof. This is going to be 100, which is C. Okay, some of these are hard. Okay, this is a C question because C is the best. B is a little too high, so 10 years experience, it wouldn't jump over that much. So that's that one. 13, 500-page picture book based on data. Number of pages printed after 10 minutes. So 10 minutes is here. So here's our line we're looking at. We have 105, which is woohoo, way off the graph up here somewhere. 31, about here. 72 would be about here. 48 here. So that one is going to be 48, D. Okay, come on, 14. Okay, so here's another one. Diego tested his engine for torque. How much torque could he expect to output at 5,500 RPM? Times 100. So 55 is here. And we have 215 to be about here. 245, which is up here. 305 off the graph up here somewhere. And 260 here. The best choice is this one right here within the line of data at 215. So number 14 is A. All right. 15 is another direct variation problem. We have 765 over 9. So 765 over 9, which equals 85. Well, 240 over 3 is 80. 255 over 3 is 85. 240 over 3 is 80. 255 over 3 is 85. So we have two that are 85. Sorry, not that one. Do that again. This one here is gone and this one here is gone. So we're left with two that are 85. So if we do 425 divided by 5, it's about the same there. So that's not going to change anything. So we have 680 divided by 7 or 595 divided by 7. So 680 divided by 7 is 90 something. Not, sorry guys, 97.1. Not 85. 595 divided by 7 is 85. So that one is J. You got to make sure on all of them they work for every one. Okay. 16. Here is a throwback question. For what value of x do the two triangles have the same perimeter? So they're equal. So we have two equal equations. This is throwback to Unit 2. Remember, combine our x's. We have 1x, 2x, and 3x's, which combines for 6x's. And -4 and -1 combine for a -5. We have 2, 1, and 1, which is 4x minus 1. So we set these equal together. We get 6x minus 5 equals 4x minus 1. Variables on one side, numbers on the other side. So subtract 4x from both sides. That gives me 2x minus 5 equals -1. I'm subtracting 5, so I'm going to add 5 to both sides. Zeroes out. So 2x equals -1 minus 5. Sorry, -1 plus 5 is a +4. Now I need to get rid of this 2 on both sides. So I'm going to divide by 2 on both sides. And x is going to equal 2. So that one is going to be C. Okay, 16 is C. 17, we need a function. Functions, when we're looking at ordered pair, we don't care about the y's. We're going to go get rid of all these y's. We don't care about the y's. We don't want to look at the y's. All we care about is the x's. Remember, to be a function, all the x's have to be different. So we have a 2, a 3, and a 2. Not a function. A 3, a 4, a 5, and a 2. Okay, that could work. A 1, a 3, a 2. Oh, there's another 1. That doesn't work. And a 4, a 4, a 4. That's definitely not. So B is the function because all the x's, we care about x's, are different. Okay. Number 18. This is a graph of a function. Okay. Remember, on the graph is where we do a vertical line test, where you draw a vertical line, and if it touches in more than one spot, it is not a function. Okay. So look here at H. It's going to touch every single, it's going to be all the same, so that is definitely not a function. J, you draw it, and it touches here and here, that's not a function. So this is, I'm just missing the letters, F, G, H, J. So on G, touches one time, one time, one time, one time. No matter where I draw a vertical line, it's going to only touch one time. So G is your function. Okay, because remember, these lines continue in both directions forever and ever and ever because it's a line. So even if you have one drawn like this, okay, over here it's a function, but right here it's going to touch more than once, so it's not going to be a function. Okay, so make sure you draw more than one vertical line so you have several different tests on there. Okay, but no matter where I draw a line on G, it's only going to touch it one time. Okay, number 19. Oh, goodness gracious. Number 19 is which one does not, this is for not, show a function. Okay, again, we don't care about the y's. 1, 3, 5, 7, those are all different. So A is a function. Don't care about the y's. 2, 3, 7, 11, all different. That's a function. Vertical line test. Only touches one time. That's a function. So it's got to be D. And why is D not a function? Because we look here at 3, it has 2 arrows coming out of it. I don't care about the y's. If my x has more than one arrow coming out of it, and 3 and 5 do, that is not a function. Remember, guys, if I come over here and do the order pair, it's going to be 3, 3, I don't know what that, 2, 2, sorry, it's 5 there. So 3, 2, 3, 5, 5, 5, 5, 8, 7, 8, and 9, 10. You have 2 3s and 2 5s, so that is definitely not a function. So D is not the function. You're looking for the forks. Do any of the x's have more than one arrow coming out of them? Do they have a fork? If they have a fork, it's not a function. And the last problem is, which of the following is a true statement? So first off, you need to determine, is it a function or not a function? Okay, well, the 3 has 1, the -1 has 1, the 1 has 1, the 4 has 1, the 5. So this is a function, and then look down here, 3, -1, +1, 4, 5. It is a function. So A says does not represent a function, B says represents a function, C says does not, and D says does. So A and C are gone because they say it's not a function, it is a function. Remember, we want x associated with 1 y. Okay. So this says y is associated with 2 values of x, and this says x is associated with 1 value of y. We want the 1 value of y. Okay. Because that x can only have one arrow coming out of it. A -3 can't go with 2 of those numbers over in the y column. Okay. The y's don't matter, just the x's. Okay. So this is your review. Hopefully you've watched this video to the end. Go back and correct your review. Any of the questions that you got wrong, go back and correct them. Shoot me an email. Shoot your teacher an email. I don't know who's all watching this. And my kiddos at home, I will give you 5 points on your lowest grade. So if you watch this video to the end, you shoot me an email. All right, good luck tomorrow on the test, guys.